In this video, I'm going to show you why signature-based firewalls, like the very popular Wordfence Firewall, fail to protect you from critical security vulnerabilities. In the video, we're going to be taking exploit code from this with a block page to successful exploitation, and then back to blocked using a runtime application system protection. Check it out. Hi, this is Corey from Bitfire with a video today about the differences between signature-based firewalls like Wordfence and runtime-based firewalls like Bitfire. In today's example, we'll be using a recently disclosed vulnerability. This was disclosed on August 17th. It's currently August 27th, so just a little over a week ago. This is an unauthenticated privilege escalation vulnerability in this donation forms by Charitable. Now, if you don't know, unauthenticated privilege escalation allows you to take an unprivileged user, say someone who's a subscriber or an editor or has zero login credentials to your website, and create privilege escalation so they can make themselves an editor, an administrator, or any other role. Now, they have a little bit of detail here about this works because the unauthenticated attacker can specify any role in the role parameter during registration. Now, I'll be showing you how the Wordfence signature team attempted to implement the firewall rule, and I'm going to show you how that signature fails. The reason that signature fails is because it's very specific to a very specific method of exploiting this vulnerability. Now, if you attempt to exploit the vulnerability using a slightly different mechanism, the firewall signature will not match and the data will be passed. I'm going to show you that in just a second. The difference between a runtime-based firewall is a runtime-based firewall is monitoring the system, checking for exactly what each permission change is doing and whether or not the user has permission to do that. So in order to update your permissions in WordPress, you're going to have to change the database tables. There's very specific tables with very specific parameters. If any user tries to escalate permissions, make themselves an administrator, or change another administrator's role, or change permissions or data for another user, every time that database query runs, Bitfire is going to run a check to make sure that the user has permission to do that. If you're trying to edit a password for someone that's not you, it's going to make sure you're an administrator. If you're trying to create a user account as an administrator, it's going to make sure whoever's currently logged in is already an administrator to allow that SQL query to happen. This way, Bitfire and other runtime-based firewalls don't need to know anything about a particular vulnerability because they handle all types of vulnerabilities. Let's see this in action. I'm going to go ahead and show you the website. Here we have a temporary password for this. Just remember, the username is wheel and the password is foobar. That's the login credentials for the administrator account. Now, if we look at the users, we have a few different user accounts here. They're all different permissions, but there's only one administrator. That's our wheel user. Now, I want to show you, we're using the Wordfence firewall. It's not optimized, but optimization really only runs the firewall for scripts that aren't WordPress scripts as well, since everything we're going to be doing is running through Wordfence and WordPress. This doesn't affect the firewall functionality at all. And I want to show you when we manage the firewall, we have all of the rules. These are all the premium rules. It's enabled and protecting. And if we go down here to look at the rules that are enabled, we can show the rules and search for charity. And here's donation forms by Charitable, unauthenticated privilege escalation. That is this vulnerability right here. And we can see that it's currently enabled, so it should be protecting us from this. Now I'm going to go ahead and switch browsers. We're going to run the exploit and see how it works. So here we have Hackbar currently loaded. This is a Firefox web browser that's not currently logged in. This is the Charitable Forms user registration form. So this is the registration form that we're going to be exploiting. And here's the post data that we're going to be sending. Now we're going to go ahead and run this. And we do that, we come back to the same point. And we have the update. Now, if you don't know PHP programming, it's not a problem. This is really simple. It's one line of code, okay? What this says is WordPress database, we're going to update the users table, and we're going to set this data right here. Here's our user pass. This is the hack. This is an MD5 hash of the password is hacked. We're going to set the user email to hacked at Firefox. I'm going to change the display name. Let's just go ahead and let that run. And we get this page. The username hacked is not registered. Now, why does it say that? It says that because when the plugin attempted to update the username, it actually updated it for our user ID 1, or our original admin user. And it updated all the parameters with everything we set, just like we saw. But then this error is displayed because when it went to load the user, the hacked user didn't exist. Because we didn't create a hacked user, we updated an existing user and specified all the parameters to the ones that we sent. Now, let's go ahead and just show you exactly that went over there. Let's select from the users. We can see we have a user login of wheel. Here's our password, which is our 4D password. That's our hacked MD5 hash. We've set the user email to hacked. And watch this. This is really amazing. We've forcibly logged out the existing administrator. Now, if we try to, let's see, log in with our old password of foobar, and we log in, it's not working. And not only that, but the password reset cannot work because we've changed the email address. So the administrator is now completely locked out. Let's go back to our Firefox tab, and we're going to go ahead and go to here. And let's log in with our new account. Now, if you remember, we set the email address to hacked at firefox.com. So we're going to copy that. We're going to put in hacked at firefox.com. And remember, our password was hacked. So let's go ahead and log in. And we've been allowed to log in. And look, we are an administrator. And the email is set to hacked at firefox.com. Now I'm going to show you how the Bitfire runtime application security system works. So we're going to go ahead and leave the Wordfence Firewall running. We don't even need to turn that off. But we're going to go over here to Bitfire. This is the Bitfire activity log where you can see every request and exactly how it was handled. Then we're going to come in here and we're going to say settings. And we're going to enable the firewall, which has been off, and we're only going to turn on one of these settings, okay? Because this is the only one that we're going to be working with today. RASP database protection. This forces the database to run checks to make sure that there's been no privilege escalation vulnerability run against the database. If an unprivileged user attempts to log in and create an administrator account or change the password of a different account or change the email address of a different account or create a new account that's an administrator, it will not allow it. Now let's go ahead and log out of this now that we've enabled this setting. We're going to go ahead and log out of the browser. We're going to come back to this page, and now we're going to rerun the exact same command, but let's change it up a little bit. We're going to set the password to updated. So that gives us a different hash. We'll come over here, copy that hash, make sure there's no spaces. We'll change the user login to not updated. And we'll change the user email to, we'll change this to, I don't know, let's say runtime. Yeah, there we go. Runtime at bitfire.co, all right? Now let's run this query. Now you'll notice it's still got to the update page, but that's the reason that is because this update line right here is going to execute, but before it does, we're going to inspect the query. And you can see here, here's the Bitfire Pro code. It's now running the query filter. And because we're trying to edit a user ID that doesn't match our existing user ID, 0 is for unlogged in users, and that user does not have permission to edit the users, we're going to block that request now. And when we look over here, we get a block page. Unauthorized user edit was blocked. Let's go ahead and actually look at our database. If you look at our database, it has not been updated. The password hash did not change. The user nickname did not change. The email address didn't change. And if we go to log in, right, we updated our password to updated. But if we try and log in, it's still the old password. Let's go ahead and go to WP admin, and we go to log in. We're going to log in with wheel, and we'll use the password of, what do we set it to? Hacked? I think it should still be hacked. And we're still able to log in. I hope this shows the difference between a runtime application system protection and a signature-based firewall. Signature-based firewalls can work, and they work a lot of the time, but they don't work every time, as we've just seen. Thanks you guys for watching so much. Please drop a comment if you'd like some more videos like this, or like me to explain more of how the runtime application protection works. We currently have runtime application protection for WordPress. We're the only RASP firewall available for WordPress at this time. Please leave a comment down below if you guys have any questions about how this works, and I'll talk to you guys in the next one. Thanks. Bye.